All right. Let's get busy then. Let's get busy today. Let's try this. Okay, so let's take a quick look at current events before getting started, actually. Where's my screen? Bring down the temperature. Okay. Let's see. 20,000 acres fire. Messed up, man. Oh, Inzoi delayed. Among primates, raising a human child to adulthood takes the longest time. Time to pick up Golang and Rust. Let's take a quick look. One good thing about the JavaScript ecosystem, if you don't like it, you only need to wait 6 months for it to have changed completely. Well, that's wild. All right. Let's go to where we're trying to go. All right. Can I log in? Let's take a look. Okay, so we're going here. And so I did do the Perl setup offline, and it did take a long time, as the person on Stack Overflow or whatever warned me that it might. But I still wish that I had done it on stream. So I'll try to do everything on stream from here, because I want it in the VODs. All right, but yeah, anyway, let's hop on to this one. And yeah, so we'll grab this, we'll open up our editor or whatever. And yeah, should be good. Okay, so we downloaded that. Let's go to exercism, Perl. Nope, let's do Loon. Yes. Okay, should we take a look at our README? I don't know if I'm... Should I be nervous about Perl? Okay, so we did this one already twice. I mean, it's not very complicated, really. I say that. Okay, so let's look in our lib. We have a loon PM file. It has a camel icon. Why does it have a camel icon? I don't know. All right, let's see. So let's go into our file and see what's in there. So it says package loon. It says use version 5.40. It says use exporter QW import. Okay. Our at export OK. QW is loon valid. Sub is loon valid. Okay, so this is going to be our Perl subroutine, I guess. Okay, so I mean, some of this is a bit different, like interesting. I think it's cool that we include a version number right here in the file, actually. I think that's kind of cool. All right. So anyway, so if we return undef, then clearly that's not going to work. Let's see what happens when we try to run our test. Let's see. How do you think we run the test? Okay, so we can run the test by going like prove. Okay, let's see what prove does. Prove. Okay, failed tests 1 through 22. Cool. And so, yeah, this looks like it's working fine. All right. So, I'm just going to echo the README right into my lib file so that I can see. Into the end of it. Okay, let's go back in here. Okay. Oh, whoops. That's not what I meant to do. I don't know. Brain fart. Okay, so let's see. So here's the whole README. I guess I can get rid of that. Let's see. Perl comments. We can do equals and equals cut. Okay. Is that right? What is the good? Is Pearl going away? That is the top question to ask about Pearl. I'm sure of it. Okay, multi-line Pearl monks. Interesting. Pearl monks. Wow. This is from 2001. Maybe Pearl is going away. Okay, so equals cut, I guess. Any decent code editor should enable you to throw a hash in front of... You know, honestly, like, yes, let's test it. Let's see how easy it is. So do we know how far down we need to go? It looks like we need to go down pretty far. So I'm just going to say, if we go all the way down to the bottom from here, can we throw the hash in front of every line pretty easily? We do know how, right? So we hit Control V. That's a visual block mode. Okay. So now I go 99J, and now I have everything blocked. And let's see if I remember this next part. So then I press I to insert, and I press hash, and I press escape, and there it is. Okay. So I kind of did that very slowly because I'm pretty dumb. So let's try it one more time. So how fast is it? Just do this. Bam. 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 You know, honestly, I feel like it's not as easy as it should be. There's probably an easier way. Like, in a lot of code editors, you just press control slash, control forward slash. Control forward slash doesn't do it in here. Anyway, maybe it's something that I just need to set up. Let's move on from all that. Okay. Okay, so we're going to try to figure out how to determine is the loon valid or whatever. And we're going to get a number passed in. Okay. So, which information do we need? Okay, that part is good. Do we need to know what it's for? I mean, I guess it's interesting, so let's just keep in mind it's for validating identification numbers. All right, now we're going to ignore that for the rest of the exercise. Okay, so let's do this. Strings of length 1 or less are, of length 1 or less are not valid. Okay, so it says it's a number, but is it actually a string? It's probably maybe passed in as a string. So let's see. Perl check type. Ref. Okay. And how do we print in Perl? Okay, we're learning. Okay, say geeks for geeks. Well, I'm gonna try to stick to Stack Overflow, I think. Okay, so we're gonna do print, I guess. Okay, this should be fun. So let's say we are going to print number. Is that okay? These guys are printing it out like something in double quotes. And then can we also print ref number? And then do we have a Perl REPL? I'm guessing probably something. Perl dash DE1. Right. Let's give it a shot. Perl dash DE1. Is this the right thing to do? Let's see. Perl run program. I don't know. Okay. So we're going to try to do Perl and run it. Okay. Okay, it should be straightforward. Oh gosh, oh gosh. How do I exit? H. Quit. Q. Okay. Okay. Perl. Lib. Syntax error. Line 12. Okay. Return undef. Oh, do we need this? Okay, so I guess it ran that time. So are they always using semicolon? Was this one? Okay, semicolon. Okay, so we need a semicolon. A semicolon is required. Okay. Okay, okay. So let's go in here and let's call the... No. Let's look at the test. Okay, so in the test, they're going to pass in a string of some sort. Okay, you know what? This is what I should have done first. Man, I feel... I don't know. I haven't been away from this that long, have I? I feel rusty as heck. Maybe that's good, though. Why would it be good? I don't know. Okay, let's see. Perl string length. Am I just gonna look up every dang thing? Wait a minute. Length. Okay. So if I go print, and we have length. Length is a possibility, right? So length number. Okay, so if, oh my gosh, Perl if state. Perl tutorial, where's the good place to go? Learnperl.org? I don't know. Let's see. Perl tutorial. Okay. So, wait. You put it after another? Okay. But we can do it with a block? Okay, yes, this is fine. Okay. So if length number, okay, less than 1, return false. T for true and df for false. Okay, do I put df then? Let's see what happens. Is that anything? Okay, so prove. Okay, so we can't run it because bare word df not allowed. Okay. Perl boolean. Oh my gosh. Okay, so we have to do something falsy like a 0. Okay, that's fine. Did anything pass? You planned 22 but ran 0? Oh, why did we run 0? Wait. Failed test. Got undef. Oh wait, can we have multiple returns? Perl, multiple returns? I don't think that's allowed actually. Let's not even bother. Let's just go in here and say, we're gonna return result, and here we're gonna say dollar result equals 0. Is that better? Prove. No? Yes? Dubious? 255? Uh-oh. Result requires explicit package name. Did you forget to declare my result? Okay. My result. Perl is a little weird. That's cool. I'm actually very interested in what is happening here. But let's try it again. Prove. Prove. Okay, so now bad plan. We got undef, undef, undef. Did we ever get anything other than undef? No. Okay, hold on. Did we get any errors coming out? Did we see any print happening? Okay, so let's try Perl. Okay, so it apparently runs. So now let's go in here and let's say is loon valid 0. Just to start with. Can we do that? Is that how it works? Oh. It shows 0, 1 grapes. What the heck? Well, that doesn't seem good. Okay, so let's this is interesting. So how did the string interpolation look again? It was in Stack Overflow. They showed one. Was it this? So they just put $1. Oh, they just put $1 in front. That's fun. Wow. Wait a minute, wait a minute. So if you want to interpolate, enclose in this. Okay, $. Wait a minute. If you want to interpolate, oh, interesting. Okay, so let's see what it looks like. So if we do this, and then put $, there, and then at the end put new line, is that better? And then here again, and put, well, I don't know about that. Let's just print new line after, I don't know. Okay, so I got a 0, I got a 1, I got a %. What is the %? I'm actually very confused. Okay. Am I very confused? Probably. So the length, I think, is 1. Okay, so let's look at is loon valid empty. Use of uninitialized value in print at line 22. Uninitialized value test in print. Okay. Perl assignment. It seems like I actually have to look up assignment in like most of these, because it's not always like the same. Assignment. All right. What are our options for assignment? Oh, this looks like a nice site. Okay, so equals, okay. As in C, I mean, that seems good, but it didn't seem like it quite worked. So I tried to be like, okay, test equals, oh wait, is it returning something? Oh no. It says return here. Should I start it at 0 like that? Is that better? Oh, I guess so. Okay. Okay. So 1 or less, I'm gonna get rid of that now. Spaces are allowed, but they should be stripped before checking. Okay, let me think. So in Perl, we should be able to use like a regex substitution, right? Perl regex substitution. Let's take a look. Okay, so this is Perl. Okay, so we just do equals squiggle at, oh, okay, amazing, amazing, amazing. Let's just do that. Okay, so new string equals old string. Wait, why is it like this? Modified copy without changing the original. Okay, well, I don't mind changing the original. Changing the original is not going to hurt anything. So let's just do... Wait a minute. Quick start? Oh yeah, let's take a quick look at the quick start. Oh, amazing. Okay. Substitution. What's down here? Search and replace. Okay, so we'll just do equals squiggle, and we'll do search and replace. And can we use, okay, well, let's see what we get. So if we say, if we print number and then say, that doesn't seem helpful. And then print, no, let's say number, we're going to replace substitution, white space with nothing. I guess so, right? Okay. And I guess we need the semicolon. Okay. And then if we print it again, are we good? I don't know. Oh, wait. We have to put the test in. Okay, so we put some with a space. Okay, so I see it with the space there, but it doesn't look like I see it. I was hoping to see it without the space, right? Okay, so we said, so we did this. Okay, so we have to probably assign something else, maybe? Okay. So we'll say my spaceless equals, and then here spaceless. Oh, I got rid of one of them. I need it to be all of them. Do I do G for global? Let's just try G for global. Oh yes, much better. Okay, so we got rid of the spaces. All right. Spaces are allowed. They should be stripped. Okay, cool. All other non-digit characters are disallowed. Okay, so we want to check for a match. Match. And, okay, so there's a ton about matching. Let's go back to the top. Okay, simple matching. So if we do this, it will say matches. Fair enough, fair enough. And then what happens? It matches if hello world matches world. Okay. Okay, so we can do a condition. Okay. So let's say if And then we'll say, oh, and this should be spaceless here. So if spaceless equals squiggle, and then we'll put just any thing that's not a digit anywhere. Is that the idea? Then here, result also equals 0, I guess. Should these be like else if? Probably. Uh-oh. Do you think it might be elif? Oh, shoot. Let's see. I saw this before. Perl. Let's go to, okay, perl doc if state. Okay, if else if. Okay, okay. Yay. All right, sure. Okay, so let's try another one, and this time I'm going to put in a disallowed letter. And let's put in something invalid because contained non-digit. Invalid because too short. Right? Okay, let's give it a shot. Invalid because too short. Okay, so we got that. Invalid because contained non-digit. Amazing. Okay, so then let's see. So we did that. And then it's showing an example, I guess, but let's get rid of that. Okay, so every second digit, okay. Man, I'm going so slow. All right. Yes, every second digit will be doubled, starting from the right. Okay, so let's use a loop. Perl for loop, yes. I'm guessing it's probably very much... Okay, amazing. Okay, so we'll say else, and then we'll say for, and we'll say my $I, like they did, I guess, equals, and then we'll say length spaceless, and then we'll say, do we need to worry about any of this other? So we'll say $I greater equal to 0. Let's just go ahead and subtract it down here. I think that makes it easier on me. And then we'll say $I subtract. Is that good? Oh, yes. Oh, yes. Amazing. All right. So then we are going to say, let's see, if $I mod 2 equals 0. Okay. So every second digit starting from the right. So let's say 1 instead. Then we will double. All right. So we're going to take a string. Let's see. Perl string char index. Something like that. At a given index, do we use substring? Amazing. Okay. So we'll need that substring regardless. So we'll say my $C equals substring, and then we'll put in dollar spaceless, sure. And then we'll put in I, and we want 1. We want the length 1. Okay. I 1. Okay. Okay, so now let's do A to I. Perl A to I. Let's take a look. Pearl, pearl, pearl. Oh gosh. No, let's pearl string to integer. Yes. Do we have a trick for that? You don't need to convert it at all? Oh, okay. We can just do arithmetic on strings. That's great. Okay. So then I will say, my sum equals 0, right? Because we're going to be adding these, I believe, if I remember. Or do we? So we double, and then we sum all of them. Okay. So my sum, dollar equals 0. Or, I don't know why I said it like that. My dollar sum equals 0. Okay. So here, what do we want to do? We will say $C times equals 2. Okay, and then if $C greater than 9, $C minus equals 9. I think this is a really good exercise for Perl. Like, this is actually, like, seems kind of cool. Maybe. Maybe. All right. So then, so we did that. Okay, so then sum plus equals C. And we're just about done, so we go out of the loop. And now we, let me see. Okay, so did we do all this? We doubled every second digit starting from the right, I think. We're gonna have to try it out and make sure it's done correctly. So then we sum. Okay, so we want this part next. Okay, so we say if sum mod 10 equals 0. Result equals 1. Okay, and we return result at the end. All right, so I'm going to get rid of the print, I think, for now. So my result equals 0. And so then we really do not need these. It should actually be if length spaceless greater equal to 1. And I'm assuming it's this. Spaceless, let's see. I'm gonna say it's probably this for not, right? And spaceless does not match any non-digit anywhere. Right? And then that should be it. And then we put the 1 there. Okay, so then what's a valid example? That one's invalid. Okay, they showed the valid example. I am gonna actually get rid of all of this for now and just try the prove again. Okay, so it says, wait a minute. Line 11, syntax error. That's specific. Okay, so what did we do? We said so if, oh, I guess I don't know if it's and. Oh, wait a minute. I just missed one of these. Easy peasy. Prove global symbol sum. Oh, I did indeed. Wait, I do have my sum. What the heck? Okay, my sum equals 0. Oh, I put it in the 4. Oh, that's dumb. That's dumb. All right. let's see, my sum. Okay, I think I still got it wrong. So we say sum here. I don't know, maybe it's better here. Let's see here. No, it still says the same thing. Did you forget to declare my sum? Oh, wait a minute. It's a grape symbol. I didn't pay attention to that at all. Okay, so that's the type. Really? Oh, that's crazy. That is crazy. Okay, for some reason I did it with the grape there. I don't know what I was thinking. Okay, let's try again. Can't modify private hash in addition plus? Oh, can't modify private hash in addition. Wait a minute. Okay, hold on. Perl variable types. So I've definitely done something wrong and didn't understand it. Okay, yes, we need the most basic of intros. Let's see. Okay, so we said $animal. We said $answer. Okay, so they're just scalars. They're just scalars. So what the heck? Oh, so the whole problem was that I had the wrong symbol somewhere. And I just didn't get it. Okay, bare word I not allowed while strict subs in use. And that's at 14. Okay, let's take a look. Okay, so, oh, yep, that is a bare word. Okay, so this is just me very much not paying attention. Okay, so it ran something, but nothing passed, right? Everything, okay, so 1. Oh, wait a minute. Did they all fail? I think they did. Okay, so failed test, a single 0 is invalid. Oh, we got a 1 there. Okay. I think that was in the README and I just spaced it. Okay, length 1, oh, what length 1 or less? I did space it, and I think I spaced the same thing last time I was here. Okay, so let's try again. Did anything pass? Hold on. Failed 3 of 22. Okay. A simple valid SIN that becomes invalid if reversed. Okay. Valid num. Oh, okay. So I didn't do it right. Let's see. Okay. SIN. Okay, let's look in the test. Valid SIN. Okay, so here's the number. Whoops. Oh, 059, is that it? Wait a minute. So 059 is the one that failed? I think so? Oh no, becomes invalid. 59. Okay, let's see what we get for 59. Okay, so we're gonna say my test equals is loon valid, and we'll put in 59. Okay, so it came out 0. Was that what was wanted? No, so this one was supposed to be valid. Becomes invalid if reversed. Okay, so now, well, this, let's see. So every time we add to the sum, I hope that we actually are adding to the sum. Let's go ahead and print sum every time. Okay, so I got a 9 and a 14. Is that what I should have gotten? I think so. In the README. Okay, so we were supposed to double, and we subtract 9 if it's greater than 9. So if we put in 5, 9, then the 9 should come out just 9. And it did. Okay. Then 14. Oh, did we not do the subtraction? So if greater than 9, C minus equals 9. Okay, so I saw it print out as 18. Oh, wait a minute, wait a minute. Am I going in the wrong direction? So we printed out 18, then 9, then 14. Okay. Of course, that's right. I'm so dumb. I think I made the same mistake last time I was on this. Well, you know what? Maybe if I ever see this problem again, maybe I won't make the same mistake. Okay, so I really don't want to do this at all. This is crazy, and I didn't realize until now that it was so crazy. This should just be 0. It should be less than length spaceless. And this should be plus, oops. Plus plus. Okay, so then here, this substring is not $I, it is length spaceless, subtract $I, subtract 1, right? Okay. And that should be it. Let's see. Oh gosh, 13. Okay, 9, 10, 10, 1. Okay, let's get rid of those prints and try it again, and I think it might be ready now. Because, I mean, it is a very simple thing. And, I mean, let's take a look. Let's just appreciate the Perl. This is the Perl, baby. I guess. I mean, I don't think it's done well, because I don't know a dang thing about Perl, but let's see if it works. If it works, it works. All tests successful, baby. All right, I'm going to turn it in. Let's see. What is it to turn it in again? Exercism, submit, lib, this. Okay, let's go look. That is the Perl, baby. Okay. So, what does it say? Passed? Hey, you know what? If it's passed, it's passed. I'm gonna move on. Yep. Anybody can look at it. I don't care. Let's return, I guess. I don't know. Code crafters. Get 40% off code crafters. All right, I'm gonna close all this Perl nonsense. So I think I've now been exposed to some of the very beginner first hour basics of Perl. So let's go to the next one. Okay, so Perl is done. So now we are going, oh, hey, we're back to our friend, Python, for the Scrabble score. All right, let's give it a shot. All right, so we've already done the Hello World for Python. Because, let's see, because we had a Python previously, right? It was this one. All right, so we're just going to jump right in. Copy that. And we will go over to our handy dandy Python. And this one is Scrabble score. All right. Let's see what it's about, baby. Okay, so it's a word game. Compute. I mean, oh, it's okay. So we're not even gonna worry about triple word score or anything. We're just gonna. Okay, well, let's just finish it quickly. Give me 5 minutes. Honestly, it shouldn't even take 5 minutes, but I probably need 5 minutes. Okay, so let's put this README into my Scrabble score file so that I know what to do. Okay, and hey, look at this. This is so nice. It just says def score word pass. All right, so I guess we're gonna return some, you know, this is funny because I actually know some things about Python. So this is gonna be a lot quicker and easier, right? So we're gonna return some, and I guess we should have maybe a dict that shows the different values, maybe. So I'm gonna just say values equals and I can have like a set, right? Probably. I'm already thinking about these things. I was just almost boasting. I know some things about Python. That was verbatim what I said. Okay, so if I want A, E, I, or whatever, so we have to pass in like maybe a list. Okay, that's what I wanted to know. Okay, so this will be set A. Let me just get it from here. Okay. And let's see. We replace like no, I still don't know how to do regex replace very well in this editor, which is dumb because I know it supports regex replace really well. I just still haven't learned to do it very well. I guess that'll be, you know what? I'm gonna write that on the list. Where is my list? Let me find it. Oof. I'm just gonna put it on my list. I'm not gonna do it right now. But yes, learn regexp replace in Vim as well as VS Code or better. Because I feel relatively more confident in doing a regex replace in VS Code. I think it's every bit as easy in Vim, if not easier. I just haven't put in the time. Yeah, that was dumb. I tried to do copy paste, but honestly, it really should just be like this. That's literally what it should be. In fact, after I did that dumb thing, I'm actually just going to change it. I'm just going to delete it. Set AEIOULNRST. That's what it should have been the whole time. DG set BCMP set FHBWY set K set JX set QZ. All right, so now if we want to, honestly, if we want to just maybe use the index as the value, it only goes up to 10, right? So I'm just going to put in a blank here because there are none worth 0. And then let me give this Scrabble score. Do we need any of this information? Not much of it. Let's just keep that much. Okay, so then, yeah, so none are worth 0. We have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, then we skip 6 and 7. 8. I don't know. It seems kind of dumb, but we're almost done. So we're going to say... So does this mean that we have to go through until we find the letter? It still seems dumb. Oh, you know what? That is why this is an interesting question, because we're trying to ask, like, what is the right way, I guess, to, like, look up the value, right? Because this isn't really the right way to look up the value. It should be, we should just look up the letter by, like, where it is in a dict, because then it's instant lookup, or not, it's a constant time lookup, right? Okay. And again, so in Python, if we go for C in AEIOU, print high C. So we can loop through the string that way. So that's really probably the... Man, I'm exposed for being pretty dumb. Okay, so values equals blah blah. Then for C in AEIO, excuse me, AEIOU values sub c equals 1, for c in dg, values c equals 2, for c in bcmp, values c equals 3, for c in fhvwy, values c equals 4, for c in k, I don't even like this either. I don't like anything. Okay, so pre values equals a e I O U 1, dg 2, bcmp 3, fh whatever 4, k 5, jx 8, and qz 10. Okay. And then get rid of that. So values equals this. Get rid of this as well. So then for v in pre-values, for c in k, values c equals v. Print values. Okay, let's just try that real quick. Oh gosh, what am I doing? Oh, I didn't finish. Okay, so yeah, sure, let's just finish. Okay, so then return some values sub c for c in, and that's it, I think. Okay, too many values to unpack. Okay, so we can't do it that way. You know, I think I just had straight up forgotten that. Okay, so A, E, I, O. Yeah, that looks fine. Okay, so then let's fix... I definitely took more... I said 5 minutes. I was like, it shouldn't take 5 minutes. And the truth is, it should not have taken 5 minutes. But whatever, I'm slow. Okay, so we set up the values. And let's just get rid of everything, I guess. Okay, score, return. Let me just put some white space in there. Okay. Okay. Let's try the test. How do we run the test again? Just do... PyTest? Says unit test. You know, I don't remember how to do this part either. So it says we are supposed to... Oh, there's a lot here, actually. Okay, so use PyTest. And what did it say? Did it say I didn't have it? Oh my gosh. No, it's like this. Okay, let's try it like that. Task equals Scrabble score test pi. No module named PyTest. Will that do it for me? Okay, let's try again. No! Oh, interesting. Okay, so it too failed. Oh, I never bothered to do the upper cases. Okay. Okay. I am gonna save that command. Because it's a kind of a longish one. Test sh. Sure. Okay. Let's submit. That one took me way longer than necessary. Totally. Okay. Let's go here. And it says solved passed. Okay, so that's fine. Mark is complete. Oh, actually, let's take one more look. Do I think that this needs significant refactoring? I'm not sure. It's like the fact that these are globals is maybe a little weird. I think that for a small script like this, that to me is kind of the right way, but I'd be curious as to whether others might disagree. And then this part, would we want to use, I think I like it this way. I guess you could probably do it with a comprehension as well. Should we try it with a comprehension just to see? So we would say, so instead of this, we would say values equals, and then we would say, C pre-values sub k for C in k for k in pre-values, right? Like you could write it like that. For this one, I think I personally prefer to use like a loop. So, because I'm not even sure this is right. For C in K, I think it is. Okay, let's try it. Nope. Did you forget the parentheses? Yeah, see? I probably did. Okay, so... Do you want to have parentheses there? That doesn't seem right. Wouldn't that make it a tuple? Let me just look it up real quick. I don't remember. Dict comprehension. Sure, hit me with it. Oh, you use a colon. Yeah. I honestly, I should have remembered that. Okay, k is not defined for k in pre-values. C pre-values sub k for k. I might have those in reverse order too. Although I'm not sure that would explain it. for C and K. Is that how it is? Okay, so that's how it is. Let's review it again. Okay, so now this is like more of a declarative comprehension, which generally speaking I like. When it's doubled up like this, though, I often get the order mixed up, and so I don't like that, but that's obviously a skill issue. So, I think this is fine. Hey, you know what? Since I redid it, I'll submit again. Why not? Okay. But anyway, let's move on. Let's move on from Python. We're going to scheme next. Okay, so that's fine. Let's go to scheme. Oh no, this is not where I want to be. 74 languages. So many. Okay. Let's go to Scrabble score. All right. So we're going to do it again, but this time in scheme. And we haven't done scheme yet, so this could be interesting. So we're going to do it like this. Let's look at what we're supposed to do. Follow the instructions at Shea Scheme. Oh. Wait, how do we choose which one we want? I'll just do the first one, I guess. All right. Release. What does brew have, if anything? Brew scheme. MIT scheme. Gerbil scheme. Gambit. Oh, here's Che scheme. Or shit, however you say it. So do we want that? I don't know. It's pretty far down the results list. But if it'll get it up and running quickly, then I'm all about it. Let's see what we get. I hope this isn't going to take too long. Okay. Amazing. Amazing, amazing. So now, we'll try the hello world. Okay. Let's see what the help says. Okay, using the REPL, that sounds amazing. Develop your solution. Oh, okay, cool. Simply type make Che if you're using Che scheme. Okay, let's try it. It says no such file or directory. Okay, so what's in the make file? We have, so make Che, and then this is what we tried to do. And then we had no luck, I guess, right? Scheme, oh, scheme, no such file or directory. So brew did not get us finished up. So was there any hint given? So we tried installing like this, all right? And then it said pouring this. So there's no scheme. Is there this? No, there's no this. Let's see if it gives any other hint. Darn. I was hoping it would be so quick. Is there anything else here? MIT, Gerbil, Gambit, Chibi, Sagittarius. Let's try the other one they suggested. GNU Guile. Will this be better? I think it might be, actually. We might already have that, actually. Let's see. Well, regardless. Hopefully it doesn't take too long. Okay. Awesome. So let's try make guile. Ooh. Oh, shoot. Oh, shoot. Oh, shoot. I just spilled my mouse. All right. Let me grab it. Just totally dumped my mouse on the floor. All right. Let's see. What are we doing? Okay. Oh, amazing. Okay, so it's working fine. So let's look in our file. Okay. It says well done. I guess that's good. So should we submit? Nope. Yeah, submit that. Okay. Mouse again. Okay, so that one's okay. So now let's go on to do the Scrabble score. We'll close these guys out. And we're going to go back and Scrabble score. So we're going to copy this. Okay. So as far as Lisps go, I think this is the third Lisp we've had to do. We did Clojure. That was early on. Then we did Common Lisp, was also pretty early on. And I think those were the only two Lisps. So now we're back in Lisp world, I guess, with Scheme. All right. So I guess we're gonna probably try and do it pretty similar to what happened in the Python version. So let me just review the Python version one more time. Python Scrabble score. So this is what we did. We put in these data points. So these letters are worth 1. These letters are worth 2. These letters are worth 3, 4, and so on, whatever. So then, of course, we can't look up an individual letter by this string, so we do this little conversion, which totally exposed me as a fraud because I don't really know how to do that very well. But we got it. And then this part, of course, is the simplest because, you know, you just look up and just add them all together. So great. You think maybe there's a little wrinkle? Like, this seemed too simple, honestly. Like, where's the double word score? Where's the double letter score? And all that. So, let's see what's in our README real quick. So, we're going to do scheme. We add up all these values. Okay, I guess it's still just as simple as before. All right, I'm nervous. Scheme. Okay, so here we go. So it says define, and then we have a score word, implement me. Okay. Import RNRS. What does that mean? RNRS. Wow. Okay. Well, fair enough. Okay, so we define this. Here it says implement me. It's got a apostrophe at the beginning, which I remember is important in the Lisps. Man, I am out of it. Okay, so if we run the thing now, if we make guile, then it says it just says implement me. Okay, fair enough, fair enough. All right, all right. So scheme map. Okay, so this is mapping a list. Scheme hash map. Dict. Okay, so a dict like in Python. Very nice. No, wait. Oh, using Python as reference. Oh, okay, well that works for me because we just did it in Python. Okay, so hash table. What the heck? Okay, I guess this is fine. Define my dict, make hash table. Okay, so then hash table set. Okay, so this is part of some kind of standard library. Okay, okay. Well, I mean, I guess this is okay. This seems a little verbose. I guess that's not a problem, though. Okay, so we put that. Interesting. Okay, well, I'm just gonna copy what he's got here. Oh, wait a minute, wait a minute. Oh, they did it through the REPL. This is one thing at a time, and they said something about doing that here as well, right? So, using the REPL, enter test scheme at the REPL prompt. Develop your solution in the file problem scheme, reloading as you go. Run a test to check your solution. Well, okay. All right. Okay, so this is working in the REPL. I don't think, yeah, you know what? I don't think this is actually answering the question. Scheme hash table. Okay. Construction. I don't know. Is this really necessary? Let's go in here and see, like, what do we want? Okay, so we're define a score word. So we know that we're going to have to break the word that comes in into individual letters, which will have to be converted to lowercase as well. Okay, so scheme iterate through string, maybe? C++, what the heck? Don't do it to me, baby. This says racket. Isn't racket separate on exercism somewhere? I think it might be. I don't remember what the... excuse me, I don't remember what the logo looks like exactly. Oh wait, here it is. Yeah, Racket. Yeah, Racket is on here separately. Here's, no, here's Clojure again. Okay. Yeah, Racket is here separately. This one's making me nervous. When I did the Lisps earlier, I like pretty much just jumped right in, I think. But I think these were also easier. Like this one is very easy. And this one is very easy. This one honestly is also very easy, but something about it, it's making me nervous. Okay, let's try to just dive in somehow. Okay, so I think we want to just say Lisp, right? Lisp, iterate through string, loop over characters in string. Okay. Oh, very nice. So map. Okay, so I saw map earlier. Lisp map. This is gonna be good. Okay, map. Oh, interesting. Apparently we have a bunch of different maps. Okay, but I don't know if this is scheme. Let's look again. Scheme map. Let's take a look. Okay, amazing. Oh, they use a lambda? Okay, I keep thinking that I have some idea of what's happening, but man. Man, I am exposed here. Alright, so we could use fold right. So we do want to use some kind of fold, right? In fact, I'm a little tempted to go back to the Python again, because technically we could have used like a reduce, I guess, right? So in here, in the Scrabble score, we could have done a reduce, right? Whoops. Is that it? We could have done a reduce with a lambda. Right? Would that be any better or different? I mean, not really. So in Python, is it the element and then the accumulator? I think this actually is obviously quite a bit more complicated compared to just using sum. I don't think that's it. Let's see what it says. Oh, I think functools is one word. This is what I get. Like, I wanna be at the point where I'm just practicing every day, but like, whose fault is it that I haven't been practicing every day? Nobody's but mine. All right, so must be parenthesized. let's see, reduce. Oh yeah. Oh, I didn't even finish it. I think it's like that. Where's Func Tools? Okay, function. You know, why don't I just do this instead of messing around? Okay, function. Okay, iterable. Okay, optional initial. Okay, so that is what I did, I think. And then the complaint was that the ACK was F. Let's see. So it was 0 here. And then we were supposed to add values sub C, which should have been an integer. Right? No, C reduce lambda C. Oh, I did. I mixed them up. The function takes, hold on. The function takes what? Ack then E? Or where is it? X, Y. You know, that didn't explain it very well, I didn't think. I'm probably just trying to hurry too much. So function. So they passed the value first. Okay, so what did I do? I passed it second. For some reason I thought that was reversed. Just more ignorance. All right. So we can reduce like that. I guess that is basically fine. So let's return to scheme. Okay, so we're all implement me. Okay, so we should be able to go like map and then then I don't. And then we put in, okay, so then we put in a sum function here. And it can be plus because we did sum in Python. So mapping of lists, go up to lists, folding. So what we're trying to do is fold it, not map it. So add up the elements of list like this. And yeah, we can use add. So then we want some initial value. Okay. Okay, but then this part, we have to change. We have to change the word into numbers for the score. So I'm thinking we probably want to go like map. And now we want a function, which maybe we can define one separate. Oh, is that what I did when I did the previous? Actually, you know what? I am going to review what I did in the other Lisps. So the closure one was very easy. I want to see the common Lisp one. Yeah, I want to review this. Okay, so yes, I did end up doing it all in different functions. That makes sense. That'll help break it down. Okay. Okay, so I'm going to define something where we get, can we do scheme string to list, maybe? String split. Construction, selecting, cutting and pasting, searching, matching, modification. So on lists, we had like reduction of lists. Byte vec. Variable length, selecting string components. Split. No, where's split? Okay, cutting and pasting, substring, string head, trim. What about this? Okay, return up to but excluding end. Okay, substring. Should I make a string to list? I feel like such a thing would already exist. However, maybe I'll just do it. And then if we define lists, construction of lists, we just put list at the front. Make a list, list copy. What about, I already looked this up, huh? Convert, okay, what is this? Convert back to the list. Okay. Oof. Okay, let's try the REPL real quick. Okay, it said in here somewhere how to do the REPL, right? It didn't say that much about it, actually. Okay, so here we are. All right, so we want to say string split hello. It says wrong number of arguments. So we needed another argument. Oops. Oh no. Okay. String split. Hello. No, no. Hello. L. Wrong type argument. Okay, so the L is no good. String split. Hello. Hold on. Scheme string split. Didn't I already try looking for this? Delimiter character? Oh. No. Wrong type argument. String split. Hello there. Okay, so no. It wants something else. So 0 is no good. Okay, hold on. Map string to symbol. That's crazy. I'm feeling quite unprepared for this one. Let's see. I think it's good. REPL command. How do I use REPL commands? Oh, a hash? No. What am I doing? Am I quitting? What the heck? Oh my goodness. Wow. All right. Goodness gracious. Okay, that's a lot. Okay, so we're in the guile. We can quit like this. Okay. Okay. Let's look at the help. Interesting. Okay, so we showed the help. Should we see all the commands? Oh my goodness. Okay, so let's quit here. All right. So what else do I want to know? Scheme string to character list. Reddit scheme. Oh, Wait a minute. Wait a minute. I think they gave it to us right there. So define string to list str, and then they said string list str. No. While compiling expression syntax error. Okay, okay. So when we define, man, I'm still tripping over all of this. Okay, so define. Okay, we can then put this part in its own parentheses, and then this part does not go in parentheses. So then we do string to list hello. Okay, okay. And then if we do string to list hello. Okay. Okay, that's that's a lot of what I was worried about. Okay, so we don't need to define that. We're good. Okay, so now we need to fold. Okay, so let's define and so the name will be letter score, and it will take in a letter, I guess. And here we're gonna be like we're gonna check. Shoot, we're basically gonna do like if, which I did do in the other one. So we're gonna say if, and I'm gonna reference that again. So we did if, so you put the condition here, and then you put what you do if it's true, and then you put what you do if it's false. But this is common Lisp, so it might be different in Scheme. But basically like that. Let's take a look. Okay, so define. Okay. Scheme character in string. Conditional. Oh man. Okay, so C in character. So unbound variable in. I was just thinking in like in Python. Scheme string includes substring, I guess. It could be either way. Searching strings. Ah, with a question mark, Okay, so substring question mark C character. Then what does it say? Oh shoot. Procedure Oh, do I not have this procedure? Dagnabbit. Shoot. Okay. So possibly, okay. Unbound variable substring question mark. So this is what they did. This is scheme. So we can try doing, I guess, that import maybe. So we go into Guile, import RNRS. Okay. Now maybe try the same thing. Substring rat. This is the example they gave, right? Pyrat. So no dice, no dice. Where did I just go? Okay, so this links to here. Okay, fair enough, fair enough. Guile scheme substring. Strings, okay. Search, okay. All right, this might be a better place to look. String contains, okay, interesting. String contains rat, pyrat. It says hash f. Okay. String contains pyrat rat. It says 2. Okay, well, that's more like it. Okay, so string contains. Okay, so I'm going to have C, C, and it says 0. C, C, D, and it says hash F. Okay, that's good, that's good. Okay, so here, we're going to say if, and then I'm going to put string contains, and I'm going to put, I guess, the first set of letters. Let me just put those into here. So cat readme into Scrabble score. Okay, so I basically just need this table, right? Okay. All right, so the first one is A-E-I-O-U, L-N-R-S-T. And the other one is letter. Is this really what I'm gonna do? I'm hating it, but I kind of want to get through this. This is one, I haven't looked at many of the solutions that are published on exercism. I did look at ones for the elixir exercise that I did. And the solutions were really cool. It was really like educational for me to see that. But I haven't looked at any others. One second. Sorry, got distracted. Okay. This would be a really good one to like look at the actual solutions. But for now, I'm just gonna say 1, and then I'm gonna say if, oh god, DG, and pretty much just like that. Okay, so I don't think I put that there. I think I need a closing for this. And I need a closing for this. Yeah, right. Are those matching? The heck? There. Okay, so if, then we do 2 here. Yeah. And then we do another if. This time it is BCMP 3. We do another if. Whoops. So we'll do a if for that. Is this how many there's going to be? Oh my goodness. Okay. All right. So then here, say that is 4. And here, this is 5. And here, this is 6. And here, this will be 7. Right? Close. Close. Oops. Close. Is that better? Well, in a way, I guess. Okay, so then here, I guess I'm just gonna put 0 for now. All right, so then, yeah, I think that's basically it. So it's gonna be map. So in the map, we're gonna put letter score as the first element. And let me look at the map again. Guile scheme map. Okay, so we do map, procedure, arg1, arg2. This is a little ugly. I don't know. I think it's okay. All right, so let's see what we want to do. Okay, so it's letter score, and then where else did I see mapping of lists MIT? Okay, yeah, this is really nasty, but okay. String to list. Okay, so this part should probably be like this. To list. Okay, but then the other thing is we need to lowercase. So let's see. Scheme string lowercase. Downcase, string downcase. Let's see if it works. String downcase. I. Okay, looks good to me, baby. Okay, so we'll map that. And I guess that's it. That's ridiculous. Okay, let's look at our Scrabble score. I mean, yeah, pretty nasty. I don't think it's going to pass either. I think there are going to be numerous problems, but let's see. It says error 1. Okay, so the compilation failed. Unexpected end of input. Okay, well, at least that's a common scheme problem. Okay, so that one matches, that one matches. Oh, I don't have a match for the if. Okay. Or for the define. Okay. Is that better? There's another one, and let's see, does it say where I need to be? 35? Okay, let's look at 35. Yep, I don't have one. Okay, so now we ran things, I guess. So that's good. We got incorrect solution probably on just about everything. But, let's see. So, it expected 1. It said unbound variable s. Unbound variable s. Okay. So that's when trying to fold. Wait a minute, wait a minute. So we tried to do letter score. Okay, so let's try this in the REPL again. Okay, so we're going to say define word hello. So just like that. Oops. Let's say it's a string though. Hello. Okay, so now if I say word, I get hello. Okay. Now, let's do string down case word. Oh, interesting. String down case word. So now it's okay. All right. I don't think we needed that in this other one. Okay, so now let's do string to list, string down case word. Uh-oh. Huh. So what's the deal with that? Can I stop it? User interrupt. Okay. String to list hello. Okay. String to list string down case hello. Oh, when I did it before, I just forgot a closing, huh? Okay, so there we go. Okay, so now let's try doing this letter score thing. Wild and terrible though it may look. Just paste that in there. It says source expression. Wait a minute, wait a minute. Okay, so can I go define letter score letter if string contains AIOULNRST letter 0, or excuse me, 1, and then I'm just going to say 0 for now. And then close the if, and then close the define, and then are we good? Okay, so now if we go letter score H, it says wrong type to apply. I don't think, so are the numbers not supposed to be in parentheses? Man, I am messing up. I am messing up. I don't think the numbers are supposed to be in parentheses. Let's try again. Define letter score letter if string contains A, E, I, O, U, L, N, R, S, T letter 1, 0. Wait. Oh. So what was this? Wrong type to apply 0. Oh, hold on. If string contains A, E, I, O, U, L, N, R, S, T letter 1, 0. Okay. Letter score H 0. Letter score E 1. Okay, so let's go out. Okay, so these ones, there should not be anything like that. It should just be 1, 2, 3, 4, 5. This should not be 6. This should be 8. What am I doing? 8, 10, 0. Okay. So it says incorrect solution. Is anything any different? Oh, it still says unbound variable s fold. Okay, we're gonna go back into got. Okay. Got it. Okay. So let's, man, I don't know if it has command history or what, but sure. So let's define again. Define letter score letter. Okay. If string contains, right? A, E, I, O, U, L, N, R, S, T. Letter 1, 0. Okay, so we defined that. Okay, so now let's go define word. Hello. String down case. Word. Now, what if you do string down case hello? Is it going to say, hey, no good? You put a literal there? Yeah, wrong type to apply. Okay, so you got to be careful. But in any case, so let's go map letter score string to list string down case word. Okay, how many to close? Wrong type. Oh, interesting. Okay, in procedure string contains. Oh, expecting string. Okay. What type of thing is that? Is that a char? char to string. Is that a thing? Okay, so unbound, let's see here. Wait, do we have, let's see help. So help language. No, that's not it. Help inspect. Okay, so scheme type of, I don't know, type of a value in scheme. Get type. Let's see here. So there's a class of, oh, a goops. Use, wait a minute. Use oop goops? Oh my goodness gracious. Okay, use oop goops. Let's give it a shot. Oh, I guess it says that's okay. So then we want to go class of, hello. Oh, class string. Okay, so then map class of string to list. Hi. Yeah? Char. Okay. So, wait a minute. Map class of. Okay, so this time a map char to string. I feel like this kind of conversion, I don't know. I feel like I want it to work, I guess. I don't know. String to list. Hi. Okay, so unbound variable char to string. So char to string is no good, but let's see. Scheme char to string. So string to number. Wait, okay, so use the string. Okay. Let's try. Map class of map string, so just string to list. Hi. Okay, so string. So can we just do list like this? What does that give us? So it gives us a list with hi in it. String to list gives us the chars. Okay, amazing. All right, so let's go back up to whatever we were doing. So we want to say map letter score. Okay. And then we said string to list, string down case word. But we want to map those to strings, I guess. So we're going to say map string. Okay. And then we're going to say string to list. And then we're going to say string down a case. And then we're going to say our word. And then we're going to close out, I guess. So yeah, that's it. That's it. Map letter score. map string to list string downcase what? Yeah. Okay. Now the next part is the fold. So let's try it. Fold, the add function. We're going to put 0 in first as the initial value, I guess. Then we're going to put what we have here. Map, letter score, map, string to list, string downcase, what? Unbound variable fold. Is that what it was saying earlier? Okay, so if we, let's see, guile scheme fold. Okay, so it says fold is here. Okay, unbound variable fold. I don't love that. I don't love that. Okay, so we did fold here. Let's try this very simple one. Let's paste this directly in. Oh, wait. No, hold on. Okay, let's try this. Nope. Oh my gosh. Okay, so unbound variable fold. Scheme guile unbound variable fold. Do you think it might be, is it under some other name like list fold or something? I don't know. I have reduce. Reduce is a variant of fold. Yeah, I mean, reduce would probably be fine. Okay, so let's just try reduce plus list 111. It's an unbound reduce. Do we want to try importing? Import RNRS reduce plus 111, right? We hope to get 3 unbound reduce. Map plus, that won't work, will it? What would that do? It says imported overrides core binding map. So that's a 1. Okay. Let's see here. I really want the well, let's see. Let's think for a second. If we don't have an option of using the fold, what do we want to do instead? I like the idea of the fold. I don't know. Scheme guile list fold unbound. I don't know. Oh gosh, oh gosh. Don't ever say organized tabs. I don't even know what it means. Actually, maybe I should just learn what it means. I don't think I would want it. Ah, okay. So this was saying fold. Oh, this is a list library. SRFI-1. Scheme? Huh. Okay. Well, I think this explains it if I had just looked. I don't know. SFRFI. Guile SRFI support modules. So are we supposed to be able to maybe like import these? Like, I don't know. Let's try. So let's say import S, what was it? RFI, maybe? It says no code for module. Well, that's messed up. That is a shame. That is a shame. Should we just try SRFI? SRFI? Nope, no good, no good. All right, well, I guess that's not going to work. Okay, so let's define our own fold. So let's say define, it's going to be called fold. It is going to take a function, an init, and a list. Okay, so let's see. So do we have like a thing to get like the top or the front or the back off of a list? Okay, hold on. Guile reference and list string conversion list. Yeah, let's take a look. Okay, empty list. Okay, predicate constructor modification mapping. No, that's not going to help. Constructor selection list. Okay, copy the first K, return the tail. What's okay. All right, so I guess we'll say if, and then we'll say length L, whoops. So we'll say if equals, and again, comparison. Okay, so if equals length L 0, then we pass back I. Otherwise, it will be otherwise we'll recurse, and we'll say we'll say F. So here we'll recurse fold. And then we have to take the tail of the list, basically, I guess. I'm really feeling a bit lost. So list selection. So we'll fold, we'll pass F back into fold. And then I is now going to be what? I here is still the same, I believe. Yeah, because we haven't hit the base case. Okay, so then L is going to be list head, maybe? List head, I guess. And then we put the list in there. And then here we put length list, or no, we put subtract length list. I guess. Okay, so now close that out. So that's that part. So what did we close there? Did we close? Okay, we closed the length. We closed the subtraction. We closed the list head. Okay, so now we're going to close the fold. But now we have to do I. Yep. Okay, so now we closed function. So now we can close the if and the define. Okay. Man, okay. Let's try folding this example. Fold cons 1, 2, 3. That doesn't look very good. Let's try a different, I'm not even sure what cons is supposed to be. Actually, what is scheme cons? Builds pairs. Okay, well, I don't think I need that. Let's just try fold. We'll put plus for our function. We'll put 0 for our init. And we'll put list of 111 for this. Okay, well, it didn't come out correctly. Messed up, messed up. Okay, so let's try again. Define fold function init list. Okay. So now we need our base case. So if equals, hold on. So let's do this bit by bit. Length 111. 3. Amazing. Equals length 1, 1, 1, 0. I didn't close it. Let's try again. Equals length 1, 1, 1, close length 0. False. Okay. Equals length 0. True. Okay. So far, so good. Let's look at let's define well, actually, oh, wait a minute. What? Oh, you know what? Where's the list tail? I don't have the list tail anywhere. That's crazy. Okay, let's just do it again with the list tail. You know, I in my mind, was I thinking I was going to need the list tail? Yeah. Did I get so bogged down in dumbness? No, I mean, just bogged down, like, not really knowing the syntax. Okay, so here this is not I. That was crazy. I was thinking, what? No, this is list tail L1. That's what it should be. All right. So now let's try folding again. Fold plus 0, 1, 1, 1. Wrong type argument in position 2. So we passed in an empty list somewhere, and we can't pass that into plus. Okay, so if the list itself, wait a minute. So we were supposed to be adding numbers together, and they should have been 0, 1, 1, and 1. But we passed in an empty list somewhere, which was where? F fold okay, let's look at this. List tail okay, yeah, it doesn't, yeah, I see the problem now. Oh shoot. Why was that what it was? What is K? Return the tail beginning with the kth element? What is last pair? Last pair. Okay, so wait a minute. How do we even get the element? Okay, so list, read, car. Do we have to do car? What is car? You know, I think I do recall this car, but what does car mean? Car 1, 1, 1. So it gives us a 1. Car 1, 2, 3. So it's the first element. How to use car in Lisp. Hit me with it, baby. Oh, come on. Load me, load me, load me. Okay, so it gets the first item, and then there should be something that gets the rest of the items, I believe, right? And is it just list tail 1? Oh, okay. Car CDR. Amazing. That's what it should have been all along. Okay. define fold FIL if equals length L 0, return I, F fold FI. So we don't want list head, that's crazy. We want CDR L. Amazing, way better. And then let's close those. Okay, and then we don't want list tail, that's nonsense. We want car L. Ah, so much better. I feel like I'm getting somewhere. This is so dumb. Whatever. All right. So is it 2 more? Oh, shoot. Define fold FIL if equals length L 0 I F fold FI CDR L. Okay, so now this is where we got to be careful. So close CDR, close fold, no, don't close function. That's probably our problem. Okay, now close function. Now close if, and now close define. Okay. Okay, let's try folding. Fold plus 0, 1, 1, 1. Wrong type. Oh, shoot. Procedure car. Oh. Okay, again. Fold FIL if equals length L 0 I F fold FI CDR L car L close fold plus 0 I don't like this REPL. You know what REPL I really like? This one. This one is absolutely amazing. Fold plus 0, 1, 1, 1. Okay, so we got 3. Okay, so I'm going to put my define fold. I'm going to copy this, all right? Because this apparently worked. No, this one. This one apparently worked. And this is going to be in here. Okay, so this is our... Man, I just spent forever on that. I just spent forever on that. Okay, so now I have defined a fold that I think works. Okay. Let's try making again. So it says incorrect. Okay, were any of them correct? What do we have here? I think I've learned something about this. I usually try to cruise through these faster than this, but man, not this time. Okay. I usually try to cruise through faster. But, oh, one of them did pass, apparently. All right, so expected 1. Okay, wrong type argument in position A. So, I don't even know at this point. Okay, string contains. Oh, you know, did I ever update that? I guess I probably didn't, huh? Because what I discovered was that when we do this, we also have to map again. Okay, is that any better? Well done. Okay, let's look at this nonsense. Can we refactor? I think so. Let's take a look. Okay, so first of all, this define fold, let's at the very least make it a little nicer. Okay, so define like this. I wish it were automatically matching. You know, should I look for something for like formatting, like a scheme auto formatter? You know, I mean, shoot. Scheme command line code formatter. Scheme format. It's only got 2 stars. Forked from Lisp Union code formatter. Okay. Is this one forked? No, this one seems okay. Code formatter. All right, so how do we use this? Building from source. I don't know if I necessarily want to do that. I might leave that alone. Okay, so if... Okay, so let's at least put that onto its own line and then this onto its own line. Okay, so then we recursively fold. That makes sense. And we use the CDR here. We use the CAR. I wish I knew it. What do CAR and CDR stand for in Lisp? Ah, here we go. Contents of the address register, contents of the decrement register. Well, you know what? That actually makes sense, I guess. But I like to just say car and cider better, I guess. How would you pronounce this? Cedar? Cider? Cedar? Maybe cedar. I don't know. I'm just guessing. Wait. Oh, really? Really? Car and cooter? Car and cutter. Car and cutter. Okay. Cutter? Okay, car and cutter. All right, so yeah, so we fold the cutter and we put the car back in there. Okay, so that makes sense. All right, so what about this define letter score letter? Like, this doesn't seem good. Can we refactor this in some way to make it less horrible? Like, look at this nested if nonsense. It's madness. Madness. I'm gonna flip. I'm gonna flip a coin. Because I'm tempted to just submit this and move on. All right. Heads, I will submit and move on. Tails, I'll try to figure something out. Here we go. Onto the floor. Heads, I'm gonna submit and move on. Okay. So I did change the fold a little bit, but so let's make again. And it says well done. Yeah, I'm gonna submit and move on. Even though it's horrible, obviously. Okay, let's take a look. Okay, it says processing. You know, I will say, I think the fold at least turned out okay. I mean, obviously it's a very simple function, but I think this is about right. And I'm glad that I figured that much out because I was so lost, like, the whole time, and I finally found car and cutter, and I'm like, oh, this makes sense. All right, so anyway, processing apparently. I don't know if it's gonna work. Okay, it says passed. So I'm gonna mark as complete and move on, baby. All right. Okay, so let's close all this scheme stuff. All of it, baby. All of it. All right, let's go to... Oh, we're gonna do it in C now. I have to say, I think this will not take me... So it didn't take long in Python. It took longer than it should have in Python, but it didn't take that long. It took forever in Scheme. I think that this will probably be somewhere in between. Maybe. We'll see. We'll see. All right. So anyway, so we have done one in C already. which I think turned out kind of okay. The circular buffer. So this was a good C exercise, I think. Let's see what we actually came up with for our C file. So it ended up being kind of a lot, but yeah, it's basically, so we have a write, we take a pointer to a buffer and a value, and then we say, okay, so if there is like some room, so the size is not yet as big as the capacity, then we will go ahead and write. So, I mean, it's a little like, this is obviously like totally copy pasted into write and overwrite. So maybe that's a little too much copy paste. It's not very dry. I think it's okay, honestly, maybe. But yeah, I think this was a good C exercise. We free when we delete the buffer. That's always good, I guess. And here's our malloc when we create a new buffer and a new content, I guess. So, I mean, I don't know. I think it's cool. So interestingly, when we clear the buffer, I just set the size to 0 and I don't free it because we're just going to overwrite whatever is in that memory. And so it's just whatever. Anyway, let's go to this next one. Scrabble score. So I don't know if this is a great like C exercise in the way that circular buffer was. But I think it's probably fine. Let's see what's in our H file. So we have a unsigned int score, which takes a word. Yeah, I think this one is pretty simple. So let's first think, are there any techniques that we want to use to make this work better? You know what? Let's just do it with a switch. Should we do it with a switch? Does that make sense? That doesn't really make sense, does it? I certainly do not want to check like the different letters one by one. That's crazy. Let's see if we have a C hash table. So here's how to implement, but what I'm curious about is there a standard library thingy that we can use? And let's see, implement your own stable hashing function. I mean, that's not really an answer to the question per se, is it? Like, it's a question of why is there none in the standard library? All right, here we go. malloc 16 GB. Well, okay. The standard library was not designed as part of the C language. You know what? This sounds like, this has 70 upvotes. This sounds like a good one. Let's just read the whole thing. Flatfinger, 5 years ago, says, the standard library was not designed as part of the C language. Instead, the language was designed so that if one needed to copy a block of storage from one area to another, one could write a function within the language to perform that task. Oh, well, now we know. This philosophy meant that if one never needed to perform a certain task, one didn't need to burden one's C implementation with the code to handle it. Okay. Interesting. I'm not sure I get this first paragraph. This part about copy a block of storage. What is this thing about copy a block of storage? What is that? Is that to do with hash tables? I'm not sure. So let's go on. So after the language was invented, after the language was invented, however, some functions that were written in C became sufficiently popular that some implementations started bundling them as a convenience for programmers. Nice. Very nice. So although having programs define functions to handle whatever kinds of formatted output they needed was more memory efficient than always bundling a kitchen sink function for that purpose, being able to simply include the prefabricated printf function was more convenient and wasn't so inefficient as to be impractical. Okay, sure. I gotcha. So printf is a very um like it has a lot of functionality. Was there some word? It's very versatile. I think that's the word I was maybe searching for. It's versatile. So like, yeah, you could just handle whatever kind of formatted output you need, or you could use the printf. Okay, so there are many ways of implementing hash tables with various trade-offs involving storage efficiency and performance given a variety of usage patterns. The hash table implementations found in frameworks like Java and .NET often use 50% to 100% more storage than the most storage-efficient designs, in exchange for being less likely to yield really bad performance when given a mediocre hash function and adverse usage patterns. Well, that sounds kind of sensible, right? So for many Java or .NET programs today, even a 100% storage overhead for a hash table may be perfectly acceptable. But at the time the C standard library was being formalized, it wouldn't have been. Professional C programmers use hash tables in situations where doing so makes sense, but they don't use one design of hash table for all purposes. Instead, they use hash table implementations that are designed to fit their particular needs. Well, I think that was not as informative as I was hoping, but good. It's a good comment. All right. I don't think it was worth reading the whole thing. Okay, so let's think. So for this one, so in the Lisp, or in the scheme, rather, in the scheme implementation, I just had a bunch of ifs. It was very ugly. The Python one, I think, is actually kind of okay. Because, you know, Python, this is the kind of thing that I tend to like to do in Python. Right? So here, we do this once at the start. So some pre-processing, and then, oh, I changed it to reduce, but I like it better as sum. I'm gonna go change it. I don't know. It was better as sum. I'm gonna go change it back. Sum makes way more sense. I just wanted to see about doing reduce. Okay, so we don't need this. Okay, so if we go back there, okay, I'm gonna submit it again. Okay, let's go back to C. All right, so even then, like, if we want to test, you know what? I think that this is a little tricky in C, maybe because maybe we don't have too many, like, convenience functions that are going to help us do this more easily for, like, string processing or whatever. And maybe there are some, and I just maybe don't know. Let's see what the README says on this one. Okay, so, okay. And for help, so running the tests, let's see, can we try making the test now? It says undefined reference to score. I think we might have to do something else. Undefined reference to score. So it's in the H, right? Okay, so it's not in there. Okay. All right, so we don't need that. So here we go. So we're going to try to define a function, right? I'm going to return a 0. Okay, so now, is that better? Unused parameter. Okay. So let's see. So that's our string. Should we maybe include like some string helper thingy? Like, let's see, C standard library string. Okay. Where's CPP reference? Strings library. Interesting. Printing. Okay. So we can do 2 lower. I guess we'll need that. So let's include string H and go 2 lower word undeclared, but oh. So 2 lower. Oh, it's supposed to be for a character? Oh, darn. Okay. Let's see what we want to do then. So we want to go what's the hold on. C print F. C standard IO. So if we say for int I equals 0, I less than, and then we have a string length, maybe? Int len equals string len word len, and then we say print f, and then put a C and a new line, and put word sub I, no, 2 lower word sub I. Is that the idea? Or, well, no, that's not the idea. But let me just try that out. So now if we make test, it says no such, okay, hold on. What was I thinking? It says defined in header C standard IO. Oh. Well, that's more like it. Okay. Um, I don't think there's anything. Oh my gosh, what is this? Oh no. I actually have no idea what that means. Wow. All right. Okay, so let's do here again. All right. Oh, I didn't have it actually run. So if we want to go GCC, can we do that? Undefined reference to main. Okay. Where, so is main in the test? Nope, 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 nope. Yeah, it's in the test. Okay, so if I do test, is that possible? No. So I want my I want my own main. So I'm gonna go. So I'm gonna include, and it's gonna be Scrabble score C or H rather, I guess. I think. And then int main Scrabble score, or it was just called score, right? Score hello, sure. Return 0. Okay. So now we want to go. Oh, no, no, not that. Yeah, we want to do this. And then we want to say O will be main. And okay. And then let's put this into something. Nope, 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 nope. Okay, so now if we main, okay, so now it prints those out. Okay, that works. That works for me. All right, so now in the Scrabble, so we printed that out. Okay, so now we don't need to print that out. Okay, let me think what we do need to do then. I don't think I need this. Um, Okay, I think I know what I want to do, basically. So I think I want to go through and let me put the um, okay, let's go here. All right, so we want these. So we'll say right. Okay, so that's all the letters, I guess. A, E, I, O, U, L, N, R, S, T, D, G, B, C, and P, F, H, B. Okay, so let's get rid of the rest of this. Okay, so what do we actually want to do? This doesn't really make much sense, right? Right? This is basically what I kind of started to do in Python and was like, no, this is crazy. Um, but like we can loop through this. I didn't want to do it in Python, of course, when I started to look at it because I was like, oh, that's so inefficient. We should use a dict. But in C, if we don't have a dict, then like maybe we should implement our own dict. Probably we should. Um, yeah, probably we should. That being said, I think I'm gonna try just looping through here. So for int j equals 0, j is less than um, should I just say 10? It's actually 11. J plus plus. All right, so then we'll say if, so then we'll say, I guess, like int j lane equals string length values sub j. And then for int k equals 0, k less than jlen, k plus plus. And then we'll say if and then we'll say word sub, or no, we'll say to lower word sub I equals values sub j sub k, return j, right? And that's it. So, I mean, yeah, I don't know. So then at the end, so in the main file, let's go ahead and print that. Okay, so I got 4. And yeah, I mean, that is the score. So let's make the test. What is this? Multiple definition of main. Oh, it tried to get it from main. Okay, well, I guess I'll comment out that then. Oh, it passed something. Okay. Let's look into the tests. I am actually having more fun with this one. I was going a little crazy on the scheme one, but I mean, in the end, it was fun, I guess. This one I'm for sure having, like, more fun. Okay, so let's look at test, ignore. Okay, so we failed some. Expected 12 was 10. Okay, so let's look at short word. Okay, so the word is at, and the score is supposed to be 2. Darn. Okay, so it came out 1, so that's pretty messed up. So in here, let's see. Let's do this. So let's say when we come to here, we'll do this, and then we'll do something like this, but it's going to be, we want the number as well. And that is going to be, I guess I probably want to look at I, J, and K. And this word sub I, does that make sense? Yeah, probably. And then here, put E. Okay, so I got 0, 1, 0, A, but then, yeah, it doesn't look like we did whatever was after that. Oh, wait, because I returned it. So this is supposed to be scoring, like, 1 letter. Okay, well, that's a pretty dumb mistake. Pretty dumb. All right. And then here, if we did that, then we want to go to here. Or we want to go to, where do we want to go to? We want to go to the end. Is that how you do it? I don't remember how that works. Go to in C. Go to label and the, oh. Is that how that goes? Some set but not used. Okay, and then what's this? Label at end of compound statement is a C2X extension. So does that mean it's not going to work? Let's see what it looks like. 0, oh, well, it looks better. It looks better. Okay, so let's get rid of the print or comment it out. And again. Okay, so now let's make test. Okay, label at end. Okay, pedantic. Okay, so label at end of compound statement. C label at end of compound statement. Oh, interesting. Yep, I had forgotten about that. Okay, so now they all pass. I guess that's good. Okay, let's try refactoring real quick. Okay, so this is what I've got. So I've got these for the values. Okay, did I actually use these includes? Here, let's get rid of this. And this. Do I need C type for 2 lower? Yes, I think so. Do I need string? Yes, I do. And then this one will whine, right? Okay, so I need those. All right, so this is here. I think that's fine. Let's put it in there. I think that makes more sense to me. Actually, I kind of tend to put it there. Is that crazy? So that, I mean, that's where it's going. I don't know. The reason I use the go-to here, of course, is because we're trying to break out of a nested loop. Should I? I think it's obvious. I think 90% of the time when you see a go-to used like this, it's for this exact purpose, to break out of a nested loop, right? Okay, so we plus equal that. That's fine. Using the len here. Yeah, I think I'd rather have this just be string len word here. And then same here. I think I'd rather just have this be string len values sub j. Okay. Interesting, interesting. So then we break out there. Instead of using the go-to, we could have like a flag. I think the go-to is the most straightforward way. We could have like a flag to say, oh, if k is less than this and something else, but nah, I think the go-to is the most straightforward. What else? I think using the values like this seems okay. Obviously, looping through that is like way more work probably than like using a dict like in Python. But I decided to do it this way because I can't think of how to do it in a better way because I don't know C. But I mean, I guess I can now say that I know it well enough to do this. It's just, it's pretty ugly. Oh, look, I don't like this here. This 11. So let's see. Can I get so we can do a size of the values, right? This number 11 is the length of values. Okay, so let's say int len values equals 11. Just, is that any better? It's not any better. Okay. Never mind. Now, if I put the wrong number here, will it tell me? Yeah. If I put a 12 there, it allows it, and it's just like, oh, you'll just have uninitialized crap. Okay, let's try running it again. Nope, I messed it up. Oh, darn. It's a size T. Darn. This one probably has to still be an int, though. Is that okay? Is it goofy? You know what? Using a size T there is, I guess, okay, but the inconsistency, like, if this one is a size T as well, is that okay? I guess it is. Okay, well, I guess I'll do that then. Okay. I guess I'm okay with that. Is the fact that we don't have anything for 0 values or this, is that bad? I don't know. Well, I think that this is how I'm going to submit it. Again, I'll be very interested to see how people have submitted this one, but I'm not going to look at it right now. Okay, so when we submit, we have to submit the H as well. Okay, let's see what it says. Passed. All right. Okay, so now let's go on to the next. Now, I'm going to stop here in 8 minutes, so I'm definitely not going to finish whatever's next. Well, I say that, but I mean, I think it's pretty darn near definite. But anyway, let's look. So the next one is called difference of squares in R. Interesting. So difference of squares doesn't sound very confusing, does it? Find the difference between the square of the sum and the sum of the squares of the first n. So the square of the sum is, so you add them all together and then square. Sum of the squares, you square them all and then add, and then you return the difference. You are not expected to discover an efficient solution to this yourself from first principles. Finding the best algorithm for the problem is a key skill in software engineering? Okay, so we already have done one in R before. Okay, so let's look at the help again. And like I say, I'm not gonna finish this tonight. But let's just see. So we can do the test that. To run the test, simply execute the R script. Library test that. So how do we do this? We run R test. Test difference of squares ignored. No. And then, are these supposed to be ignored? Source, difference of squares R, library test that. What's in my difference of squares R? This is a stub, should return. Is that any different? It says argument test difference of squares.r ignored. Let's see. I don't remember how you run. Here, let me You know, my brain is like Swiss cheese, honestly. Okay, so R. Okay. How did we do this? Simply execute this R script. All right, I'm definitely on basics. Wait a minute. Okay, here we go. File. Is that better? No, it still says ignored. Unknown option file. What was it? Oh my gosh. Just dash. Oh, equals, equals. No, 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 no. I don't see why I would. Okay, file equals. What the? Okay, so we ran it. Okay. Okay, so now it shows, oh, something passed? Oh, something was 0. Okay, then something failed. Okay, I'm almost ready to get done. So the the actual question seems kind of simple, so let's just kind of maybe do just a regular naive implementation, I guess. Now, do I know how to do it in R? Not really. Like if it were in Python, or let's even just do it in JavaScript real quick. So like if it were just a super naive thing, um, it might be like, well, actually, I don't know. Oh, my thinking is so uptight. Like if it were Python, I think Python maybe first. So we would say sum, right? Something like that. And then we would say, let's just say n equals 100. Sum x for x in range n, right? And then the other one would be sum x for x in range n square, right? And then you would just subtract those. Now it told us that we need to look for an efficient solution, right? So, I mean, if I do it some different way. So I know in R we have a lot of like sort of vectorized type operations, right? So range in R. Yeah, here we go. In fact, let's open up the R Studio. I think that's what I did last time. If we just crack open the R Studio, can we zoom this? I'm gonna zoom it about that much. Okay. To make it easier to see in the volume. All right. So if we say range 10, then, oh, interesting. Range 0, 10? No. Okay, what's the thing with the range? Range, blah, blah, blah. The minimum and maximum of all the give. What the? Okay, so we can do help. And it shows it there on the right. Okay, fair enough. Okay, so what we don't want is a range. Do we want, what if we do 0 through 10? Okay. Range vector in R. Yeah. Oh, okay. 0. Ah! Okay, so do we have some? Okay, okay. So then we can do some Okay, now if we do 0 through 10, we can do times 2. Can we do this? What about this? R power vector. Raise a number to the power of a vector? What? Oh, okay. Wait a minute. So now if it's vectorized, okay. C. Okay, so we did power. Okay, so power. Okay, so let me just copy this. Okay, so power 0 through 10, 2. Okay, much better, much better. And now we can do sum. Okay, okay. And then we just reverse it. Power sum 0, 10, 2. Okay, so those were the numbers given in the example, right? Oh gosh. I don't know how that happened. So we did 30, 25. Oh my gosh, how did I screw that up? Get back in there. All right. So those were given in the example. Efficient solution. So let me see. Yeah, I mean, it seems simple to the point that, like, okay, so if I just copy this, the real question is, like, what is the efficient solution, right? Okay, so power. Let me copy from this person again, I guess. Okay, so we want to go power sum and go 0 natural number, I guess, and then go 2. Sure. Subtract sum power 0, 0 natural number 2. So it says test passed. So I mean, yeah, I want to go to bed, so I'm going to submit this. Well, I'm not going to go to bed right away, but I want to get ready. So let's do it. Okay, let's see if it's accepted. And then I'm gonna get out of here. It says passed. I'm just gonna say it's done, I guess. I mean, I don't know. Because it's saying an efficient solution, right? And it's going to Project Euler. So, man, I feel so dumb these days. I'm gonna go walk outside. I'm gonna try to think about this. Because presumably we should expect that there is an efficient solution that runs in less than linear time, right? The solution that I just sent runs in linear time, right? I don't know why I said it that way. It's linear time, and I think because we have to iterate over everything and sum them, right? So what it's implying, I think, is that there is a better than linear time solution, right? Probably something like a constant time solution if we just do the algebra or whatever it is to figure out like how to get an answer in constant time. I think that's what's being alluded to here. I don't know if I've actually seen this problem before. It might be one that I've seen before, but if so, I don't remember. So yeah, I think now it might not be that there's a linear time solution necessarily. It might be more like n log n, I guess. I don't know. I think it's linear time though. I think there's a formula that we can use to discover it. And it does say research is encouraged, so difference of squares that's what it was called, right? Difference of squares, but this is I'm so old. I'm so old, and it's been so long since I've practiced even basic arithmetic, honestly. It is, should we look to where it linked on Project Euler? It says 100, right? So in R, did we test that? Is it in the tests? Yeah, we did 100. And in Python, it spat out the number fast as well, right? You know what? Oh gosh. I want to look at the next one. WASM! We're gonna do it in WASM, baby. I'm not gonna do it in WASM tonight. Let me, you know what I want to finish tonight? The WASM Hello World. Okay, so it looks like we're just needing Node and apparently like not any of the WASM specific tooling. I have tried some WASM specific tooling before, but I mean, I don't know hardly anything about it. Like, I try all these things and, like, learn nothing. Like, that's what I've been doing this whole time. Okay, let's go out to WASM. Hello, world. I try all these things and learn nothing. It's ridiculous. All right. So, let's see what the help says. Oh. Oh, wow. So this is enough help to hopefully get you started on WASM, because I'm guessing that there's probably like the WASM learning materials that are out there online might not be super well suited for doing something like this, because this is like not something that WASM is really meant to be doing exactly, solving puzzles with it or whatever. Like, it's meant to be a compilation target for other languages, I guess, usually. I mean, I don't know. So, unlike many languages, WebAssembly code does not automatically have access to global resources such as the console. Such functionality instead must be provided as imports. Okay, okay. A standard library. Okay, of functions. Okay. So these are things that are specific to exercism, I guess, right? And we have logging for different types. Okay. Okay, so, oh, okay. I'm okay with this. So it ended up a little verbose, but that's all right. Okay, so now if we want to do the test, we can just try npm test. Let's just try npm test. Says module not found. Let's try npm I. Like, even though I complain and I'm like, oh, I try a million things and learn nothing ever, and my brain is like a sieve. Like, I am having fun. That's why I keep doing this. It's silly that I don't know anything. It's silly, quite frankly silly. Okay, so hello world, say hi. Expected 13, received 14. Interesting. Expect greeting to be hello world. Okay, so let's take a look at our hello world what. Okay, interesting. Okay, so here is our WebAssembly. It looks like kind of straightforward. So here's our module, memory export mem1. Okay, interesting, interesting. We have some data, I32 const64. Okay. Return a greeting. The final number must match the length of the new string. Okay, okay. So do I understand this? So data, I32 const64. Okay. And so we know 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? Okay. Func. This actually seems pretty nice. I think. I mean, I'm impressed. I'm excited about the way it looks. So let's try running that. So it says pass. So I guess I'm going to submit because, I mean, there's not much to do, obviously, on a hello world. That one? Yeah. Okay, let's see what it says. Okay, processing. Passed. Okay. Sure. Now, let's go back to difference of squares. Let's take a look at what this one looks like. And like I said, I'm going to stop soon. But I'll be back tomorrow. Okay, module. Calculate the square of the sum of the first n natural numbers. Oh, interesting. So for this one, it looks like they actually filled in some stubs for stuff that I didn't even know. Wait a minute, wait a minute. I think this is a clue as to the answer, which is that instead of iterating through to get the sum of these squares, we should use a formula. Now, I do seem to recall a formula which, okay, so let's see. So let's go iterative, let me just say I equals n. And so for this one, I'll just say, what do I want to say? Just use a 4. Have I even done this right? Man. Yeah, okay, that's fine. What do you mean I is not a function? Interesting. I don't think I was expecting that, but yeah, sure, let me just call it IS then. Okay, so I think that seems all right. Then, so I think the formula is something like n times n minus 1 over 2. I feel like it was something like that. Am I crazy? Yeah, I'm way crazy. What was that? Oh, no, 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 no. That's the formula for the sum of just the n's. No, shoot. Was it maybe plus 1? Okay, so that was the formula. All right, so now can we tweak that formula to do squares instead? Well, this is a formula that we can use because since we can do this to get the sum, then we just need that square. So that's actually one of the formulas that we need, right? That's one of the formulas that we need. So now can I write that as R? Hold on, let me look. Where did this go? Okay, yeah, where did this go? All right, so difference of squares. Let's go to maybe Python and see if difference of squares is in there. I'm guessing probably yes. So let's go to language tracks. Let's try Python. Oh, it's right here, Python. And then let's find, where do we search here? Practice, maybe? Difference of squares. Okay, so it's an easy, of course. Good. So let's copy this. Okay. So oh yeah, look. They did it just like this. Okay, so square of sum and sum of squares. Okay. So this one we know is like completely straightforward. We just do square of sum number subtract sum of squares number, right? So now we know that if we can solve both of these in linear time, then the whole thing is linear time. Okay, so we think we know sum of squares. That's the easier one, I think. So we want to say return, and we want to say number times number plus 1, right? Divide 2 square, right? Okay, so now for this one, let's just do it iteratively real quick, and then I'm probably gonna think about, I actually don't want to look it up because I think I might have enough memory of something if I dig it up out of my dumb brain. I think I might have enough memory of something once I've dug it up to maybe do this without looking up more information than I've already looked up. I'm not sure. But for now, let's try just doing return sum, and we'll just do it in linear time, basically, right? Of n square for n in range, right? So that should work, but this one, let's put in a note. Note, not the efficient solution. Okay, so then let's try that test again. And what does it say? Oh, gosh. Okay, so I didn't, oh wait. Sum of squares 5, okay. Oh. In Python did or excuse me, in JavaScript did I think it was right? Where did it go? N times n plus 1 over 2 square. And is that the one it was complaining about? It was, right? Or was it? Sum of squares. Yeah. And I got 225? I think I got it backwards. Sum of squares. Yeah, square of sum is supposed to be. I don't know, man. I don't know, but sure. Sum of squares. Okay, so we have to add one here. And I got a none. Why did I get a none? Difference of squares. Oh, I didn't put the return. Okay, so it says okay. So I'm gonna submit like that, and I'm gonna call that the end for tonight. Assuming that it accepts it. I think it does. For some reason, it opened over here. Okay. So it says passed. So I'm gonna end. I'm gonna think about it, and maybe I will know a different answer. So if we're looking at this, obviously, like, it's pretty easy stuff. But, like, here, we're doing it iteratively when I think what they're alluding to is the idea that we have another formula. And they said to just look it up. And if I can't think of one, I will look it up, of course. But I want to try and think back and see if I actually remember this. Right? So, honestly, I don't think I do. But I definitely, like, in school, I did stuff that was kind of like this. Like, I had Calculus 2. I got a C in Calculus 2, though. In Calculus 2, I did well on the integrals part because it was just a continuation of Calculus 1. It was fun. I did well. And then we had series, and I wish I had done well on series, but I didn't.